Hello. Uh, as I promised in the previous video, I will introduce a new probability concept for the fair comparison. So what we would like to compare is this probability. The probability of promotion if the candidate is female, and the same probability if the candidate is male. So this looks pretty much the same, like probability of promoted female, promoted male, but actually it's different. Here, male and female in this definition, being male or being female is an outcome. Like you just randomly choose a candidate and check if the candidate is male or female. But now, in this definition, you know that this like there is a pool of female candidates and choose a random candidate among females. So you already knew that this candidate is female, and given that knowledge, you are checking whether randomly choose and check whether the candidate is promoted or not. So female is not an outcome anymore. It is a condition. It's known. You know that. You assume that it already happened and you know that. And then let's see how many times you observe promotions. That's the idea. Then how can we calculate them? It's like this. So imagine like in my mind. So the data, there are 1200 candidates. First, you classify, divide them into male and female. And then among 240 females, you randomly choose and count how many are promoted. So then, out of 240 female candidates, 36 are promoted, which is 15%. On the other side, among 960 male candidates, 288 are promoted. So out of 960 male candidates, this many are promoted, which is 30%. This is now comparable. This is what you had to compare. And the difference is the denominator. I am adjusting the pool size. So remember these numbers. I'm going back. You obtain 24% as this 288 divided by 1200. But now later, 288, the numerator is the same, but the denominator is adjusted. The pool size shrank to only male candidates. And similarly, so if you use the total number of sample like 1200, then this probability would be 3%. So 36 over 1200 was probability of being female and promoted. But now by changing the denominator, restricting the pool size to 240, you get another probability, which is 15%. So this makes more sense. And then as a result, still after adjusting the pool size, still the probability of promotion is higher for men than women. So you may say that this can be an evidence. Uh, this is a reasonable evidence for discrimination if everything else being the same, right? So still, it's the difference is like double. The probability is double, but previously without adjusting the pool size, adjusting for the pool size, it was 8 times larger. So 8 times is an exaggeration. Maybe some the reason why the difference, the some of this difference is generated from caused by this discrimination, but more is caused by the pool size. So So the previous comparison was not a reasonable comparison, but this is. It is reasonable and better, fair comparison. So let me define this idea. Let me formulate this idea. So we define conditional probability. To define a conditional probability, you need to have two events. Of course, you need to have two events because conditional probability should be written in this way. Probability of an event A occurs given that B has already occurred. So there must be an event which serves as the condition. So when a condition already is satisfied, what is the probability of another event? That is the basic structure of conditional probability. So you should it's simple, easy to understand, but later when we define notation and makes questions complicated, then it gets very confusing. So be more careful. We denote it as probability A given B. Probability of A bar B. So the vertical bar stands for condition. So the condition comes after the bar. So remember the order. The first one is the main event of interest, and the second one is the condition. So B already happened. So you should distinguish them. And then, how can we calculate the conditional probability? It's easy. The idea is, as I said, we are changing the denominator. You have to adjust the denominator, change the denominator according to the condition. So you erase simply. So think about this probability. We are calculating the probability of promotion given among male officers, given male. Then how can we calculate that? Simple idea is to erase the observations that do not satisfy the condition. The condition is male. So that means female observations do not satisfy the condition. So we don't care. That do not satisfy the condition, we don't need them. I'll delete this when I calculate this probability. Then simply the pool size is now smaller. Pool is now smaller. I restricted the pool only to male candidates. And then denominator is only these guys, not everyone, but only these two types of outcomes. And then numerator is the same, the promoted, those who are promoted. So out of this many, we are calculating this outcome, probability of this outcome, which is 30%, right? Again, the idea is ignore the observations that do not satisfy the condition, right? Pretty intuitive. Okay, then you try this. What is the conditional probability of promotion given that a candidate is female? You can apply the same idea to calculate this probability. Simple. Try this. You may use a calculator, Excel, whatever you want. So just try this. You can do it by hand, whatever you want. Okay, I'll turn the page. So again, delete male observation. I don't need them. Delete. And among these guys, among the female observations, the probability of promotion is, so treat as if this is the only information, then it's either promoted or not. So the probability of promotion is 36 out of the total number, 112, 120. So the probability is 15%. So I believe it's straightforward enough and intuitive enough to understand. Okay, and another thing you should be careful here is, as I said, the condition is coming after the bar, but a lot of students are confused. What's the condition? it's particularly dangerous because P given F is different from F given P, right? So remember, so F, the second one, that comes after the bar is the condition. And here it comes after, P is coming after the bar. So when being promoted is the condition, I'm deleting these guys. So you are deleting different data. So if you mistake the condition, you are using totally different set of data. So let's see what happened. If P is the condition, you delete this, right? So then you only have this many candidates. So among promoted, I'm calculating female. So among these, only 36 are female. So the probability is only 11%. Remember, it's different. So promoted among female was 15%, but female among promoted is different. So uh, you should be careful and you remember this. And I don't worry too much for this course. For this course, uh, like whenever you are confused, you may open the slides or like you can search online what is what. So when you do the homework, then you can just uh, check again. And repetitions make you better. So you have chances later to review this redo these exercises. So you should be fine in the end. And then as a formula, usually so far explanation so far I think should be enough, but textbooks usually give you a more uh, dry formula, and the formula looks like this: probability of given B, A given B can be calculated as frequency of A intersection B divided by frequency of B. So remember, the denominator is the pool, or the condition, number of observations uh, that satisfy B, and in the numerator, in addition to B, A should happen at the same time, right? So you may interpret this definition more intuitively. It can be understood as a definition or formula, but I already explained the idea enough, so it should not be confusing. So in the next video, I will use more realistic data, real actual data. So whether smoking increases the risk of high cholesterol or not. So I will stop here and continue this in the next video. See you later. Bye.